Hello YouTube and welcome to my channel. This tutorial is intended to be the continuation of the previous tutorial, and in this tutorial we are going to work on the design of transient simulations with the translational motion within that. So this particular video is only going to be about how you can assign the translational motion and how you can do the excitation and the boundary conditions for this. So let's just start with that. So if you remember, let's go first with assigning the translational motion in the transient simulations. First thing first, you have to make sure that your simulation is in transient simulations. So to do that, you click on the Maxwell 3D and go on the solution type and make sure that the transient is selected. As soon as you select the transient, now you can have more options that you wouldn't have in the other types. First, click on the band and tell them the simulator that this is the band that every motion will be happen inside it. So we select the band, we go to the Maxwell 3D under the model, and we go to the motion setup, and then we say assign a band. As soon as we say assign a band, it will ask us what kind of a motion we have. In this case, we have a translational motion along the z-axis, exactly what you see over there. In the data, it's a bit tricky. The initial position, always remember, for the initial position, put the same value that you put for the negative position. So if you remember, we had 0 over here and we have minus 5 millimeters down. So we want to this guy goes from minus probably 3 millimeters and go up all the way to whatever 10 millimeters. So that will be our motion. So I'm going to put minus 3 millimeters over here, and start of the negative is going to be again 3 millimeters, and the positive is going to be, I don't know, 10 millimeters on the positive side, maybe 7 millimeters or 8 millimeters. Okay, and next thing is what's the speed of the motion. So if you remember here, we have minus 3 to 8, so it's 11. So let me put it like 7. So it's exactly 10 millimeter of movement. And let's say that we have this 10 millimeter of movement for 10 millimeter per second. So in that case, all the simulation time would be one second. In 1 second, we have a 10 millimeter movement, which is the intentional movement that we are going to simulate. Press OK on that, and you should be able to finish that. Now, the next part is going to be, so what do you want to do with this? So let's say there is a current going to be excited inside the coil. How do you want to see the current? If you just do the excitation, you have to add a number to the excitations. I will show you what I mean. Press F to be able to select the faces, and select the faces of the coil, and right click on that and go to the assign excitation and go for the coil terminal. You can call this one terminal number 1, and you can put the number of conductors to be 1. If you put more than 1, then it's a stranded. You can have like 1000 stranded, so the effect of eddy current will be less. Go with 1 and press OK. Remember, it was going inward, and for this one your current has to be outward. So let me just rotate this, and this time I'm going to select the face again and make sure that I'm exciting the T2, and over here I'm going to make sure that the direction is going to be outward. Press OK. Now when you select this, you will have in the excitation terminal 1 and terminal 2. In order to be able to tell the Maxwell that these guys is an inductor, you should call it the windings. That's how basically Maxwell will understand that this is an inductor, and I'm gonna treat it like an inductor from the beginning. So what you do is you go to the excitation, right click on that, and say I want to have adding the windings, and we call it coil, for example, and we say that the coil is gonna have so just let it to be coil. And now I'm going to go and right click on terminal 1, add to winding coil, right click on terminal 2, add to winding coil, and when I go to the coil now, it tells me that okay, you have a solid, you can make it stranded if you put more than one. By the way, remember that if you put more than one for the number of conductors, you have to put a stranded. I put one, so it's a solid conductor. And now it asks you that how do you want to excite this coil? We don't want to excite the coil. We are actually intended to see. So we need to be able to tell the simulator that okay, this is going to be only to see how much current is going to be excited inside due to the fact that the magnetic pole is like moving inside. To do that, you have to say this is not going to be me exciting it, it's going to be excited outside through the movement. So the trick here is to use external. Now, as soon as you say external, it says what's the initial current of that, which is definitely 0, and you press OK. Now, the simulator expects you to define an external circuit and connect that external circuit into your circuit. And to do that, it's very simple. You just right-click whatever you want and go on excitation, and over there go to find the external circuit, and then say edit external circuit. Okay, pretty cool. And then you say edit circuit. And I happen to have a circuit right here. I wish I wouldn't have it. So let me go and make it from the beginning again. So I'm going to go from the beginning. You press new, and then over here you go in the most recent one you can find windings. If you can't find it, go to the search and search for winding. And even if you can't or you can go to I believe you can go to the passive elements, and you can find, so there is a difference between inductor and winding, by the way. Winding is when you are connecting it to your Maxwell, but inductor is like just an element you can use. Yes. Okay, here under the duplicated elements you can find windings. Anyway, so go select the winding and bring it over, and double click on the winding, and make sure that for the winding name you put exactly the same name that you put for the circuit over there. So the circuit called winding over there, coil, the winding that we add. So here we have to put it coil as well. Press OK on that, and then you can just bring a resistor, and 100 ohm is fine. And then you just say, okay, let's say that the terminals of this winding or this coil that I had was connected to a resistor. How much current goes to the resistor? Or how much current, how much voltage you will have across this resistor. To don't get an error, what you want to do is you want to put a ground one side of the resistor. It doesn't add any problem, but it just like gives you a reference, and it will work for you. So you can save it if you want. You know, I just like go like here, probably I say call it external, and press OK. And then in the Maxwell circuit, you just go export the netlist, and you say netlist, export netlist, and save. And as soon as you do that, it should automatically understand that you exported the netlist, and it should stop. Oh, it doesn't do that. So you cancel here and you just import circuit, and over here you should have exported netlist. I hope this is the one that I made. Yeah, it does look like the one. So just press OK. And it says that successfully it successfully imported. So you just go and press OK, and now what you have is these two guys are now connected to resistors of 100 ohms. That easy. Now what you want to do is okay, so you want to go to the Maxwell 3D, and over there in the excitations you want to select the set eddy current effect, and you want to make sure that the eddy current is in effect for the coil, and because that's basically what you have that creates the so I select the eddy current on the coil and press OK on that. Now, one other thing that you can do is you can select some mesh. So for example, you can go on the coil and you can right click on that and say I want to assign a mesh. Inside selection length base, and you can say I want to have at least 10,000 mesh elements. So it will start from this assumption. Right click on the analysis, and over here you know that your stop point should be 1, and you can have a resolution of 0.1, and same deal over here, you want to have 1 and resolution of 0.1, and you want to replace that list, and that's it. You're good to go. So right now you finished the excitation, boundary conditions, and external circuit edition of the circuit, and you're good to go for simulating that. So let me just move this and see. That's what we are supposed to get. And I'm going to do the checklist, and as soon as I validate, it should be all validated with the green check marks. This is how you finish this. Okay, great. So you can actually save this project as well, and then start running the simulations. I will come back when the simulation is finished, and that will be actually the third section of this tutorial. If you have any questions and any concerns, please put that in the comment below any videos. Do not put it in the message board of the channel. It's pretty bad to manage it. And if you have any design, please send it to my email, and we can go follow that from that